our computers every single day. But have you ever really stopped to think about what's happening just beneath the surface? Right under all the apps and the icons we click, there's this entire hidden world of software that's working around the clock to make everything run smoothly. Today, we're going to pull back that curtain and take a look at this hidden world. It really seems like magic, doesn't it? You just click and boom, your program opens up. But how? I mean, what's the secret sauce that turns that one simple action into a full-blown application running on your screen? Well, that's exactly the mystery we're going to solve today. The answer, it turns out, is a special class of software called system programs. Now, unlike the apps you choose to open, like a game or your web browser, these programs are the essential unseen workers. They are the bridge connecting you to the deepest, most fundamental parts of your computer. And that quote really hits the nail on the head. See, the core of your operating system, the kernel, is incredibly powerful, but it speaks a totally different language, the language of hardware. System programs are the master translators, turning our simple clicks and commands into something the kernel can actually understand and execute. Without them, your computer would basically just be a very expensive paperweight. So to really get how these programs act as that critical bridge, we first need to understand the landscape they operate in. It's time to start peeling back the layers of the operating system itself. Probably the easiest way to picture all this is with an analogy. I want you to imagine your entire operating system as a super modern, high-tech office building. Everything is designed for peak efficiency, and every single part has a very specific job to do. Way down in the basement, you've got the kernel. This is the building's concrete foundation, its power grid, its plumbing, all the critical infrastructure. It connects directly to the hardware, the very ground the building sits on. But as a visitor, you never, ever see it or talk to it. It just works, powering everything from below. And here's how a simple request flows through that building. Okay, so you, the user, are a client who just walked into the lobby. You don't shout down to the basement, right? No, you go to the user interface, that's the receptionist. The receptionist then passes your request to the right specialist employee, and that's our system program. To get the actual work done, that specialist sends down an internal office memo, which we call a system call, to the core infrastructure in the basement, the kernel, which finally performs the task. All right, so now that we know where these specialists work in our high-tech building, let's take a closer look at their actual job descriptions. What does this team of system programs really do all day? This team has a massive list of responsibilities. Seriously, they're in charge of checking the system's vital signs, managing every single one of your files, connecting you to networks, and even loading and executing the very programs you want to run. Let's just zoom in on a couple of their most important roles. Think about this. Every time you create a new folder, or rename a document, or delete a photo, that's a system program in action. They're like these incredibly meticulous digital librarians, managing the entire library of your data and making sure every last file is exactly where it's supposed to be. And what about browsing the internet? Well, that's a completely different specialist's job. The communications programs are like the building's diplomatic envoys. They go out, establish connections, and manage all the information flowing between your computer and the outside world. Without them, your machine would be totally isolated. So we've got this beautiful, intricate system, this perfectly efficient office building where everyone's doing their job. But we all know that in any complex system, things can and absolutely do go wrong. So what happens when there's a problem? What happens when a program, or even the whole system, crashes? That's when a completely different team gets called in. These are the digital detectives, and their process is called debugging. When a crash happens, it's their job to show up at the scene, cordon it off, and start gathering clues to figure out exactly what went wrong. Now, these digital detectives don't just show up empty-handed and start guessing. No way. They have a whole toolkit full of powerful instruments designed specifically for uncovering clues and solving even the most baffling system mysteries. Their number one tool? Log files. Think of event logs like the security camera footage. They answer the question, what exactly was happening right before the crash? Transaction logs are the financial ledgers. They help detectives figure out, how can we restore the data and get things back to normal? And message logs, they're like interview transcripts telling the detective who was talking to whom right when the problem started. Now, when it's just a single application that fails, the system can generate something called a core dump. And this is an amazing piece of evidence. It's like a perfect snapshot of the program's memory, its final thoughts, at the precise millisecond it terminated. For a developer, that clue is absolutely priceless. And this brings up a really crucial difference in scale. A core dump is for investigating the failure of one application, a single employee in our office building. But a crash dump, that's for when the entire building goes dark. The whole operating system has failed. The crime scene isn't an office, it's the entire building, so the evidence you have to collect is way more extensive. And even with a full system wide crash, the detectives have options. A complete dump collects every single shred of evidence, the entire contents of memory. A kernel dump is more focused, grabbing only the operating system's memory. And a small dump just snags the most essential clues needed for a quick first look at the problem. The Detective's Toolkit also has other advanced gadgets. Trace listing is like putting a tail on a program, getting a moment by moment report of every single move it makes. And profiling is more like conducting a performance review, analyzing which parts of an application are being slow or hogging all the system's resources. Okay, so we've met the specialists who make our computers work and the detectives who swoop in to fix them when they break. Let's zoom back out and really understand why this hidden world is so incredibly important. Ultimately, what it all boils down to is this. This entire hidden ecosystem of system programs and debugging tools forms the invisible backbone of modern computing. It's the one thing that transforms a powerful but complicated box of wires into the stable, reliable, and user-friendly devices we all depend on every